Greetings one and all and welcome to this math video. In this video, we'll be considering a vectors problem. And notice that we have here a quadrilateral. It's a quadrilateral because it is a four-sided figure. Notice we have the side AB, that's 1, BC is 2, CD is another one, and DA is another one. And so this quadrilateral has four vertices, A, B, C, and D. And notice this vector, notice the vector AB. The vector AB based on this diagram is X. And the vector the vector BD is 2X plus 6Y. And the vector CD is equal to 2Y. And so they're saying, in light of this information, seeing that we have given you this information, we want you to express AD and BC in terms of X and Y, but we want it in simplest form. So we want you to simplify what you get. That's what you have to do for A. And then for B, we want you to write two geometrical properties of AD and BC. So with this understanding, with this in mind, let us proceed in the following way. Let us answer first question AI. So for AI, they want us to determine what is AD, right? AD. Now, AD, what does AD means? AD means we're going to start at A and then we're going to end at D. We're going to start at A and then we're going to end at D. So how can we get to D starting from A? Now we can move from A to B, and that's why we have this here, and then we can move from B to D, and that's why we have BD here. So AD is going to be equal to AB plus BD. But what is AB? Well, AB is equal to X. And what is BD? Well, BD is equal to 2X plus 6Y. 2X plus 6Y. Now let us group our like terms together. So we have X here, and we have 2X here. So let's combine them. So this is going to go here, and this is going to go here. And then we have 6Y right here by itself. Now, what is X plus 2X? Well, X plus 2X, you can look at it as saying, what is 1X plus 2X? 1 plus 2 is 3, so therefore 1X plus 2X is indeed 3X. And so the answer, and then we bring down the 6Y. So the answer for AD is that AD is actually equal to 3X plus 6Y. And this is the correct answer. We can stop here. But you can also factor out the 3. So we factor out 3 because 3 is in here and 3 is also here. Notice that 3 times X is 3X, and 3 times 2 is 6. And so 3 times 2Y is indeed 6Y. So these two are saying the exact same thing. They're just expressed in different ways. Okay, so now that we know what AD is 3 times X plus 2Y, let us determine what BC is. What is BC? Now BC, the vector BC, means that we're going to start at B and we're going to try to get to C. Now, how can we do this? How can we start at B and then end at C? Which route can we take? Well, we can start at B and then go to D, and that's why we have BD here. And then from D, we can go to C, and that's why we have DC here. So let's do that. Let's start at B and then go to D. BD is actually 2X plus 6Y. So BD is 2X plus 6Y. How do we know that? Right from the diagram. What is DC, however? What is DC? Well, we know that CD goes in the downward direction. So CD goes in this direction. But we don't want to go in that direction. We want to go in the opposite direction. And CD, we know that CD is equal to 2Y. So CD, which equals to 2y, is heading in this direction, but we want DC, right? We want DC. And DC is heading in the opposite direction. So DC starts at D and goes to C. So that means that these two vectors are going in the opposite direction. So CD is going in a downward direction, DC is going in the upward direction. Now, if CD equals 2y, then that means that because they're going opposite directions, DC must be equal to negative 2y. Okay? So that's why we have that DC is going to be equal to negative 2y. So DC equals negative CD, which is equal to negative 2y. With this in mind, let us continue. What is a negative multiplied by a positive? A negative and a positive is indeed a negative. So let us continue. We know that 6y minus 2y is simply 4y because 6 minus 2 is 4. And we have 2 here, 2x. So this is going to be 2x. We bring that down. So all in all, BC is equal to 2x plus 4y. You can stop here, right? This is correct. But here I decided to factor it. So notice that we have 2 times x is equals to 2x and 2 times 2y, which equals to 4y. And this is the answer. BC is equal to 2 multiplied by x plus 2y. Let us continue. Our last part of this question is B, and it states, write two geometrical properties of AD and BC. First, let's consider, we want AD and BC. Let's consider what is AD and what is BC. So AD and BC. AD and BC. So you want AD and BC. So let us erase this. So BC is going to, and they're talking about the vectors AD and the vector. We're talking about the vector AD and the vector BC. And note that AD goes in this direction and AD is here. And BC is here. And from the onset, just by looking at these two diagrams, these two vectors, and by looking at this diagram, we can see that clearly AD is bigger or longer than BC. So let us continue. Note that what did we see that AD is equal to? Remember that AD, based on what we saw earlier, AD is 3 times x plus 2y. That's what AD is, 3 times x plus 2y. And so that's what we have here. AD is equal to 3 times x plus 2y. Now, what we can do is we can take this x plus 2y and we can express it in a different way. So this x plus 2y is the same thing as let's look. Let's look at this. So let's consider this. Notice that notice that I should explain it like this. Notice that these two, a better way to explain it is the following. Notice that these two, we have an equality between them. And you might be saying, well, how is this equal to this? What this is saying is that AD, we can express AD as 3 times x plus 2y, but we can also express AD as 3 over 2 times 2, open bracket, x plus 2y. Now, how are these two things equal? Well, indeed, they are equal, and I'll show you. Notice, let's consider this expression here, right? Let's look at that. We have 3 over 2. 3 over 2. And multiplied by 2, open bracket, x plus 2y. Now, let's look at this. Notice that because they are adjacent to each other, so 3 over 2 is next to 2, or I should say it like this. Notice that 3 over 2, this expression, what this really is saying is that it's saying 3 over 2 multiplied by 2, and multiplied by not just 2, but not just 2. This is not saying, my apologies, this is not saying that 3 over 2 multiplied by 2. It's saying 3 over 2 multiplied by this entire expression, 2 times 2x plus 2y. And so let us do that. So we have 2 multiplied by 2x, 2 multiplied by x, which is 2x, and we have 2 multiplied by 2, which is going to be 4y. So again, we have 2 multiplied by x, which is 2x, and 2 multiplied by 2y, which is 4y. Remember, we have the 3 over 2 here, so that is 3 over 2. All right, 3 over 2. Now, what does this mean? Well, this means we're going to take 3 over 2 and we're going to multiply it by the 2x. And what is that? That's simply 3 times 2, which is 6. So that's 6x over 2. And then we have 3 over 2 multiplied by 4. And that's going to be, what is 3 times 4? Well, 3 times 4 is 12. So that's going to be 12 times, because we have 3 times 4y. So it's going to be 3 times 4y, which is 12y. And we cannot forget our 2 at the bottom. And so we have to add them because we have an addition here. So we have 6 over 2x plus 12 over 2y. Now what is 6 divided by 2? Well, 6 divided by 2 is indeed 3. Okay? And so that means we have 3x. Okay? Now what is 12 divided by 2? Well, 12 divided by 2 is indeed 6. So this is 6y. 6y. And so we have that this expression, 3 over 2, times the entire expression, 2 open bracket x plus 2y, is equal to 3x plus 6y. Now let us factor out a 3. So we're going to remove a 3 out front. So we're going to pull out a 3. And this can be factorized as the following. 3 times x plus 2y. Now you may be saying, Isaac, why is that the case? Well, notice that if we say 3 times x, that is 3x. And if we say 3 times 2y, that is 6y. And so what this means, and hopefully you can see it, is that this expression, 3 over 2 multiplied by this entire expression, is actually equal to 3 times x plus 2y. And that's exactly what we have here. We have that, 3 over 2 times 2, or 3 over 2 times this entire expression is equal to 3 times x plus 2y. And so since these two things are equal, that means that AD, this factor AD, is actually this expression in disguise. All right, so AD, the vector AD, can be written appropriately just like this. Now, what is this expression here? What is this? What is that? Have we seen this before? What is that? What is 2 times x plus 2y? Right? What is that? Have we seen that before? Let's go back to our question and notice, look, that's exactly BC. BC is 2 times x plus 2y. And so therefore, all we need to do is, instead of putting 2 times x plus 2y, let's just put BC. So that means that AD, right, AD is actually equal to 3 over 2 BC. So AD equals to 3 over 2 BC. Now, since we have found a number that we can use to multiply by another vector to get the other vector, that means that the vectors A and D, the first thing is that they are parallel, right? So if we have a number that we can use to multiply by one vector to give us another vector, we say that these two vectors are parallel. So since AD equals to 3 over 2 BC, this means that the vectors AD and BC have the following geometrical properties. What geometrical properties that they have? Number one, they are parallel. Because we have a number, we can find a number that we can use to multiply by one of them to get the other one. Also, we know that the vectors AD and BC, not only are they parallel, but they are scalar multiples of each other. Now, because AD equals to 3, 4, BC, the next thing that we know is that they have the same direction. And fourthly, we know that the vector AD is 3 over 2 times longer than the vector BC. So these are the geometrical properties that we have. And that brings us to the end of this video. Thank you for your time and attention.